All right, we're talking about how to find a slant asymptote. Now, what I want to do right here, they already graphed the slant asymptote for us. So what I want you to do is just come up with the equation of this line. The blue line is the asymptote. And we could tell it has, it's just a basic line, y equals mx plus b, right? And it seems to have a slope of 1 and a y-intercept of 1. So it turns out the slope, or the slant asymptote here is y equals x plus 1. Okay, now how could we get that from the equation, from this rational function? Well, here's the deal. If the degree of the numerator is higher than the degree of the denominator, we just divide, and our answer is going to give us the equation for the slant asymptote. Isn't that cool? So we're going to do long division here. And yeah, we do have to go back in time and remember how to do long division here, but it's not that bad because in this situation, we actually don't even care about the remainder. I mean, you can go ahead and find it if you want, but it's not relevant for finding the slant asymptote. So I have every term here. I don't have to worry about placeholders or anything like that. So I ask myself, what times x squared equals x cubed? Well, that would just be an x. I'm going to put that right here. So if I multiplied everything by an x, I would get x cubed, right? I'm multiplying all this. X cubed, negative 2x times x is negative 2x squared. Negative 3 times x is negative 3x. Then remember, I'm subtracting this whole thing, which means that this becomes a negative, that becomes a positive, that becomes a positive, and then I can just add. Okay, cancels. A negative 1 plus 2 makes 1x squared. Negative 4 and positive 3 makes negative x, and bring down the 4. What times x squared equals x squared? Well, that would just be a 1. Boom, so we have a positive 1 here. And at this point, I don't even have to do any more. You can go ahead and do it if you want, but what we're going to get from here is just going to be the remainder. And so this is the only part that I care about, and voila, what do you know? That is the exact equation that we found for the slant asymptote. Is that a coincidence? No, it's not. It will always work that way. It's pretty cool. So let's do another problem then. But let's do this both ways. Let's say we're trying to find it using long division like we just did. No big deal. That's easy peasy. That's a simple long division problem. We have every term, and we're good, right? So again, what times x equals x squared? Well, that's just x. So put an x here. And go ahead and distribute that. So I'd get x squared minus 3x. And then I'm subtracting, so that turns into a negative, that turns into a positive, then I can add. That cancels. A negative x and a positive 3x makes a positive 2x. Bring down the 2. But again, it doesn't even really matter from here because I really just need to know what times x makes 2x, and the answer is positive 2. And I could keep going if I want. Let's go ahead and do that here. I would get 2x minus 6. Again, I'm going to subtract, so that becomes a negative, that becomes a positive. And I would get, these would cancel, and my remainder would be 8, right? And if I was to actually write this as an answer, it would be x plus 2 remainder 8, or x plus 2 plus 8 over x minus 3. But again, we don't care about that. We just care about this. So the slant asymptote for this, for f of x here would be y equals x plus 2. That would be the slant asymptote. Sure hope I'm spelling that right. Boom. Now, what if I want to do it synthetically? Just a little reminder. I really only like to do synthetic if it's a nice simple linear equation with an a value of 1 that we're dividing by. You can do it if this is like a 2 or 3 or 4, but it's just more complicated. And in that case, I prefer long division. But if you really want to do synthetic that way, I have a video in my IM3 class. I think it's IM3 1.5. And it talks about long division and synthetic division. And you can absolutely feel free to do that. But let's say I'm just going to do this synthetically. You need the 0 on the bottom here, which would be 3. And then you need all the coefficients, which would be 1, negative 1, and 2 of the top. I like to put a line here, a little box here, because that's where my remainder is going to go. I drop down the first one. It's a 1. I multiply and add 3 times 1, right? 3 times 1 is 3. So I put a 3 here. Negative 1 and 3 makes 2. 3 times 2 is 6. 2 plus 6 is 8. And then I backfill. This first term, I'm going to go this way. This first term does not have an x. This would get an x. If there was more, it would be an x squared, x cubed, and so on. So it's x plus 2. So we could just basically say x plus 2 remainder 8, which is the exact same thing we got over here. So we can verify, yes, absolutely, the slant asymptote is just y equals x plus 2. I think that's pretty cool. All right, so let's take a look. So here we got some more exciting problems. Now, again, if you really want to do this synthetically, you can. The basic thing you have to do is you got to find the 0, which would be negative 1/2, and that's what would go in your corner. Then before you do synthetic, you have to divide all these by 2. And then at the end, you also have to remember to multiply your remainder by 2. Again, all of that I think is just too much. I'd rather just do long division. There's nothing wrong with it. I don't have any placeholders here. It's actually pretty straightforward. And again, I don't even have to like really finish long division. It's only a couple steps here. So what times 2x makes 4x squared? Well, that would be another 2x. So I'm going to put a 2x here. And then distribute. I'd get 4x squared plus 6x. Okay, then I subtract, which means this is a negative, this is a negative. That cancels. 2 minus 6 is negative 4x. Bring down the negative 7. Again, though, this doesn't even really matter. I really just care what times 2x makes negative 4x, and that would be negative 2. And, I mean, you can test it if you want, but essentially we are done. We have our slant asymptote. It's y equals 2x minus 2. Boom, boom, boom. Now, if you do want to keep going, sure, go ahead. You get negative 4x. Negative 2 and positive 3 makes negative 6. And then you could subtract. And then these would turn into plus, and you get a negative 1 as a remainder. But again, we don't care about that. We just care about what we get here as the answer. Okay? All right. So I want you to try example 4 on your own. Maybe pause the video. This one might require some placeholders, right? So I'll set it up for you all. I would write it like this. 2x squared plus 3x plus 0, because you don't have a ones term, over 6x cubed, or not over, sorry, but and divided into 6x cubed plus 13x squared plus a 0x minus 5. Go ahead and give that a shot. You can't really do long division for these types because there's multiple zeros, so it just doesn't really work out. Not really possible if you have a degree other than 1, but this will still work. So go ahead and give it a shot. Long division always works. Pause the video when you're ready to check your work. Okay, I wrote it out. The first thing I did, what times 2x squared makes 6x cubed? And it would be 3x, right? 3x times 2x squared makes 6x cubed. So I went ahead and distribute that all along here. I get this answer. Then I subtract. Remember, I'm subtracting every term, so 13 minus 9 is positive 4. And then I don't even actually care about these other terms, guys. It doesn't even matter because I'm at the end of this problem. I just need to know what times 2x squared makes 4x squared, and bam, I have my answer. 2 times 2x squared makes 4x squared. Again, I could keep going here, but I don't care about the remainder. So what's the equation of the slant asymptote? It's just y equals 3x plus 2. Beautiful, easy peasy, lemon squeezy. Let's keep going. All right, so what if they're asking me about the end behavior? This is the exact same problem, by the way. Boom, boom, boom. So we already know that the slant asymptote is 3x plus 2. So let's just write that down. So I'm going to write slant asymptote is y equals 3x plus 2. Is that right? Yeah. All right, so what I would recommend, if they're asking about the end behavior, is then let's just talk about, let's think about this guy. Let's think about this guy rather than the actual equation. So if I think about just this guy, let's sketch out what this would look like, right? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Just real quick. Now, a y-intercept of 2 and a slope of 3 means I go up 3 over 1. So it's going to look something like this. Well, that's all I really need to know the end behavior, because if I think about the limit as x approaches positive infinity of g of x, well, as this thing goes to positive infinity, this thing just goes up towards infinity. So it's going to have the same end behavior as this rational function. I just have to think about this line. And what's the limit as x approaches negative infinity of g of x? Well, that's just going down to infinity, so that's just negative infinity. So boom, I got the end behavior. So slant asymptotes, pretty easy stuff. I hope you enjoy it. You just get to do some long division. It's beautiful. See you guys on the next video.